Chapter 6, Part 3, Bonds and Bond Valuation. This is the final part of bond markets and bond valuation. Following are the learning outcomes from this presentation. After going through this presentation, students will be able to deduce the price of zero coupon bonds. They'll be able to calculate both the current yield and the rate of return from a bond, or for that matter, any security. They'll be able to connect the relation of bond ratings and bond issuance, and actually find out how bond ratings can actually sink a company sometimes. They'll be able to describe the different types of government debt by the end of this presentation. So first, let's analyze what's a zero coupon bond. As the name suggests, a zero coupon bond does not pay a coupon, which means that there are no intermediate cash flows. So what do they pay? Well, they pay only the face value at maturity, which implies that as long as the rate of discount, or YTM, is greater than 0%, the price at any point of time will be less than the par value. That's a simple present value formula that we use, right? Price is always present value, and present value is always discounted future cash flows. And if the only cash flow is $1,000, its discount price, as long as the rate is greater than 0, will be less than 1,000. We can see that. So let's just see what the price of a zero coupon bond is. It's just a simple present value equals future value divided by 1 plus r to the power n, or we can use the PV function. So we can use both these methods to price a zero coupon bond. So let's assume that there's a bond that matures in October of 2035. And let's assume that today is April of 2025. Assuming that this bond has semi-annual compounding, the number of compounding periods would be 21. To find that, let's just go to Excel. So in Excel, let's just put here April 1st, 2025, and then October 1st, 2035. And in Excel, we can actually take a simple difference. It's just better to calculate it manually rather than Excel, but it can be done in Excel. So equals this divided by, there are about approximately 181 days and 6 months. So it's 21.18, and we can truncate it. So using the trunc function, we can just truncate it to 21 semi-annual periods. Now, the way we can find out is the future value, or the face value, is 1,000. The number of periods, NPER, is 21. The YTM, or the discount rate, is 2%, but semi-annual. So the periodic rate will not be equal to 2%, because 2% is annual, but for the whole year. But since there are 2 compounding periods per year, it'll have to be 1% as a periodic rate. So the first method, we just use a PV function. PV function. And if we use a PV function, it equals PV, the rate is 2% divided by 2. The number of periods is 21. The payment, there are no intermediate payments to zero coupon bond. And the face value is negative 1,000, type 0, 811.43. We could also use the formula. Using the formula, all we have to do is 1,000 divided by parenthesis 1 plus periodic rate to the power of 21, the number of compounding periods, which gives us the same answer. So we can find out the present value or the price of a zero coupon bond using any of these 2 methods, the PV function or the formula. Going back, so our answer is 811.43 using both these methods. Now, a couple of more terms for bonds which we must know. Actually, the second term is common to all kinds of financial instruments. So the current yield of a bond, or any instrument for that matter, is the annual cash flow divided by the price we paid. So what is the return on our investment realistically if we don't intend to sell the financial instrument is the concept of the current yield. So we bought this bond at 9.20, and this pays a coupon of $40 per year. Now it might pay two $20 coupons, but as you can see, current yield therefore becomes a slightly back of the envelope calculation. Going again to Excel, it says 40 is the annual coupon, 9.20 is the price, and the current yield is not the YTM, it's not the coupon rate, it's just coupon annual divided by price in percentage. Shift Control 1, so that's 4.35%, and that's exactly what we get. Now the next concept is called the rate of return. Rate of return is similar to the current yield, except now that we've sold the financial instrument, we could have made a capital gain or a capital loss. So in this case, again, same thing. We purchased the bond at 9.20. We got one coupon of 40, and then we sold the bond for a loss of 95 after 1 year. So the rate of return is first part, the coupon divided by price, and the second part would be the capital gain or loss divided by price. So let's just break it down. So rate of return is current yield in percentage plus the capital gain, or in parentheses loss, thanks to the selling of the instrument. So in this case, let's use the same concept. Suppose we lost money in this bond by selling it for, I forgot, $8.95. Thank you. So the capital in this case loss, but I'll just call it gain. Negative gain is loss, right? So equals parenthesis selling price minus purchase price. We lost $35. $25. So minus 25 because it's a loss, divided by the original purchase price. Pardon me. The original purchase price, just like before, we had, pardon me, H3, the original purchase price, times 100, and Shift Control 1. So there are two components of rate of return. So the first component is current yield, and the second component is capital gain in percent, and the rate of return will be the sum total of these two. So in this case, the rate of return is 1.63%. We can do this in another straightforward way. Equals parenthesis the selling price minus the purchase price plus any coupons or payments that we received in between, divided by the purchase price times 100. So Shift Control 5, Alt O E, tab, oops, number, go to number and make it 2 decimal places. So 1.63%, same answer as this one. So that is called the rate of return. So let's just look at the formula. It's a sale price minus purchase price plus any coupon or dividend, etc., in case of stocks, distribution, that is, divided by purchase price times 100. So it's 1.63% for this case. Now, bond ratings are very important. Bond ratings are just like a credit score that individuals have. For example, as an individual, if you have a score of 811, you're considered to be highly credit worthy because your score is very high. In the case of corporations, it's not a number, but it's a grade. And in our case, just like there are 3 rating agencies, Experian, Equifax, and TransUnion, in the case of corporations, there are 3 rating agencies: Moody's, ICRA, and Fitch, S&P and Fitch. So worse the rating, worse the grade they have, the greater the likelihood of default. In fact, sometimes when these rating agencies threaten companies that they will downgrade them to a worse rating, their likelihood of borrowing becomes worse, which means that they are unlikely to borrow with as much creditworthiness as they were before. It's just like individuals. So these rating agencies are S&P, Standard & Poor's, Fitch, and Moody's. Now let's move on to government bonds. Wait. Let's go back. So bond ratings are A, B, C, and D, just like our grades for a corporation. So sometimes Standard & Poor's would be saying you are AAA. AAA means really good. AA, slightly less good. AA, single A, even less better. Triple B, well, it's worse than single A. Double B, less than triple B, and so on. In fact, if it's a C, it's called a junk bond. That means it's not really worth it. As in the case of individual average grades, C is probably either just average or below average. Now let's move on to the discussion of government bonds. Government bond is related to the ability of repaying for the whole country's government. In the case of United States, not only does the US government have a credit rating, but as does its state governments, municipal governments, etc. So the central federal government issues three types of bonds. Treasury notes, which mature between 2 and 10 years from the issue date. Treasury bonds, which are long-term, 10 years or above. And bills, which are very short-term, that is less than a year. And then the state and municipal bonds are also existing there. So what do you think is more creditworthy? The federal government bond, the state government bond, or a municipal bond? Well, which of them has the biggest might? And that's the logic that is used here. The US dollar is printed by the US Treasury but circulated by the Federal Reserve and is the most well sought after government debt in the world. So Treasury bonds and notes pay a coupon semi-annually. Treasury bills are like zero coupon bonds, not really, but they're priced in a similar way, and their pricing is beyond the scope of this presentation. But bonds pricing is similar to the present value of annuity plus one cash flow of the face value at the end. So it's similar to the pricing of corporate bonds that we saw in chapter 6 before this presentation. And bills are like zero coupon bonds, but their maturity date is less than a year, and the pricing is beyond the scope of this presentation. To conclude, zero coupon bonds have only one payment and therefore are also called as discount bonds. Rate of return and current yield are two ways to measure what is it in for an investor from a particular bond. Credit ratings are very important for determination of creditworthiness of these corporate bonds. And so they help or harm a corporation from borrowing in the debt markets. Government debt is considered to be the safest debt, and it's created either through treasury bills, notes, or bonds. But state and municipal government also borrow for the needs of their own jurisdictions. And that's chapter 6, part 3. Thank you for